Hey everybody, it's Mrs. Gauthier, and we are doing homework for 614 today. All right, so this one's a little bit shorter too from last night, so that's a good thing. All right, examine the graph at the right for number 36. Write the directions and translate the original triangle to make a new triangle, or make the new triangle. So here's our original, right? Here's our new one. We need to say like what happens as far as our slides go. So from our original, that's about at -3, right? If I'm looking at this point first, I should probably tell you what point I'm looking at. I'm going to look at that point. And I'm going to find that same point on this shape right there. So I'm moving over 3, right? So 1, 2, or sorry, no, I'm moving over 2. 1, 2, 1, 2. There we go. Or 1, 2 up here. I just like to count on the axes, but so I would say I slid right 2. All right, so that would put me here. And then how many down did we have to go? Well, 1, 2, and 3. There's my 3. Down 3. Perfect, just like that. All right, for letter B, it says what are the coordinates of the vertices of the new shape? So that means this is our new shape. We need to tell what the new vertices are, the points, right, are. So this first point that we moved, he didn't move. He moved 1 to the left from the origin, right, when we're naming our points. So that would be -1. And then he didn't move up or down at all, so just 0 would be the first point there. This next guy is right on the origin, so that makes it really nice. 0, 0, right? And then our last point down here, we moved over 1, so again, -1. How many down did we go? Well, we went 1, 2 down, so -2. So those would be the 3 points of our new vertices. All right, letter C, says on our graph, reflect the original triangle over the y-axis, and what are the new coordinates of the triangle? All right, so our y-axis is this line right here, right? So we're reflecting it over that line. It means it's going to flip from this side over across to that side. So I'm just going to start by measuring our points and getting our points on here. All right, so we measure how far away is this first point. You could pick any one, it doesn't matter which one you start with, from my line of reflection, in this case, my y-axis. I know that I am 1, 2 away, so that means that I need to move 2 to the right, from starting at that y-axis. So 1, 2 to the right would be right about there. It does help when you have like some grid lines, but in this case, we don't have any. We'll make do. All right, this next guy is 1, 2, 3 away. So now I'm going to go 1, 2, 3 about, right, away from the y-axis or the line of reflection. And last but not least, this bottom point is 1, 2, 3 points away. So 1, 2, 3 points away for him as well. And then we can connect our points here, and you can see that it's the same shape, right? It's just flipped over onto its other side. Okay. Alrighty, and then we need to name these points. So this first point right here, right, is over 2. So down on C here, I'm just going to name these 2, comma, and then how many up was it? 1, 2, 3. So 2, comma 3. Right. All right, my next point over up here was 1, 2, 3 over, and then up 1, 2, 3 as well. And my last point right here, he was over 1, 2, 3, and up just 1. All right, so those are my new vertices points. Now, number 37 says that we are given this rule, right? Y equals -3x plus 1. We need to make a table and a graph for this rule. So I like to go from -2 to +2. So -2, -1, 0, 1, 2. I mean, we could go 3, 4, 5, 6. Those are easy enough numbers to fill in. Now, we know our 0 number, right, is given to us. It's right there, 1. So I can fill that in. Then my growth. I am growing by taking away tiles, and I'm taking away 3 tiles every time. So 1 minus those 3 tiles would be -2, right, because I'm moving into the negative region. Negative 2 then minus another 3 would be negative 5. Sorry, I'm going to write 3. Let's not do that. Okay, minus 3 again, negative 8. Minus 3 again, negative 11, right? Just keep subtracting 3 every time. Okay, now to work backwards, right, we're just going to be adding 3 tiles on. So this goes to 4, and then it would go to 7, right? All right, so we have our table. Now to graph it, right? We can graph these points. If that is easier for you, you can just go ahead and graph the points, or I can use the rule, remember, to graph. So I could start at my y-intercept of 1. That's my first point on my y-axis. I'm going to be going down 3, 1, 2, 3, because it's negative, and then over to the right 1. Down 3, 1, 2, 3, over to the right 1. We can see we're going to have a negative slope. I can also grow my line in the other direction by starting at my original point, going up 3, 1, 2, 3, and then to the left 1. 1, 2, 3 to the left 1. Okay, so we have lots of points on our graph here. Make sure that you do really kind of fill in your graph. Don't just have like 2 points. All right, sorry, I'm not using a ruler here, so I'm just trying to freehand my line. There we go. That's him. Okay, so there's my line. We could flip it over and do our backside here. Okay, so solve the system of equations using equal values method. And it gives me them. They're nice because they're already an A equals something. So I'm going to drop off the A equals and put them equal to each other. So that would mean that I have 12b plus 3, right? That side of the equation equals, right, equal values method, negative 2b minus 4. All right, I'm trying to solve for b in this case. So I'm probably going to add my 2b on both sides. I like having positive variables, as you guys know. So when I add those together, 12 plus 2 is 14b, plus 3 stays the same, equals negative 4. Then I need to move my 3 over, right, to be with his friend. So subtracting 3 to make that 0 pair right there. And then I end up with 14b equals negative 7. Then I need to go ahead and divide by whatever number is in front of my variable, which in this case is 14. B is going to equal a fraction, but I can simplify this into negative 1/2, right? All right, so that's what B equals. Well, how do we figure out A? Well, guess what? We have to plug it back into each of our rules. So A equals, I'm going to do this first one, top one first, 12 times, what was my B? Negative, in this case, I'm going to put it into a decimal form because I like working with them a little bit easier than fractions. Okay, then I can go ahead and multiply, right? So I would have to do that before I do my addition. So 12 times negative 0.5, and then plus my 3 is going to give me negative 3. And I go through and multiply that. Then I'm going to plug it into my second equation to make sure that it works. So negative 2 times negative 0.5. And then minus 4. And when I multiply first and then subtract, A equals negative 3. All right, excellent. That one's done. Moving on here. So if I was supposed to write this as my point, right, I would have, well, it doesn't really tell us which one's the x and which one's the y, so I won't worry about writing a point. If it was x and y, then I would write this solution, but we won't worry about that right now. All right, number 39, Mr. Callie's class is studying a tile pattern. For the rule, the tile pattern is y equals 10x minus 18. Callie thinks that figure 12 of this pattern will have 108 tiles. Is he correct? Justify your answer. So what we're going to do is plug in this number, right, back into our rule. Okay, so we're going to rewrite, here's our rule again, y equals 10x minus 18. And we're saying, oh, I think there might be 12 in figure 12, how many tiles are there? So I'm going to plug that in for my x. So y equals 10 times 12, right? Because our x represents our figure number, which in this case was 12. And we're going to solve this. And hopefully, if he's right anyways, we should get 108. All right, so y equals 10 times 12, we know is 120, minus 18. When I subtract that, I'm getting 102. That means he is not correct. Nope. And for justifying our answer, this is what we could show for justifying it. It should have, figure 12 should have 102 tiles in it. Okay. All right, next one, number 640. Angel is picking mountain blueberries for a delicious pie. She can pick 1/6 of a cup of blueberries in 2 minutes. She needs 2.5 cups of blueberries for the pie. How long will it take her to pick the berries? All right, this is screaming to me that I need to set up a proportion, right? I know that in 2 minutes, she can pick 1/6, right, of a cup of blueberries. I could convert that into a decimal too if I wanted. It'd be like 0.3 repeating, or no, 0.6 repeating. All right, and then over on the other side, I don't know how many berries or how long it's going to take her to pick, but I know she needs to end up with 2.5 cups of berries, right? I can go ahead and I can cross multiply here. Oops, cross multiply. There we go. Okay. And then when we multiply, right, we would end up with our 0.6 repeating x equals our what am I doing? Our 2.5 times 2. I'm going to use this as a, well, here, I'll use parentheses. Then we don't get confused with the decimals. And when I go ahead and solve this, I end up with 6 equals 30, right? So, that tells me that in 30 minutes, she can pick 2.5 cups of these mountain blueberries. All right, last but not least, number 41. There we go. All right, so we have Juan, and he thinks that the graph of 6y plus 12x equals 4 is a line. We need to solve Juan's equation for y. So I'm just going to rewrite it here. 6y plus 12x equals 4. All right, so we need to solve for y, so that means I'm going to get rid of my x's first, deal with those variables first. Minus 12x on each side, so that would leave me with 6y equals, I can't combine these terms, so negative 12x plus 4. Then I need to divide, right, by my coefficient here. Divide by 6, which leaves me y equals, let's see, 6 goes into 12 2 times, so negative 2x plus, now this does not, 6 doesn't go into 4 nicely, so I'm just going to leave it as a fraction. I can simplify it, though, to 2/3, right, by saying how many times 2 goes into each of those. So his new equation in y equals mx plus b form, y equals negative 2x plus 2/3. All right, part B. Is this equation linear? And also, is its graph a line? Explain how we know. Well, it is going to be a line in this case because when we look, we don't see any squareds, any of those like little 2's, right, or 3's or 4's, or any little exponents in our equation. So we know that, yes, it's going to be linear. Yes. And we know it's going to be a line because, well, 1, it is linear, and 2, because it's in y equals mx plus b form. It can be written in y equals mx plus b form. If it is not, it will be in quadratic form or some other form that you'll learn about next year. We just worry about linear for now. All right, last bit, letter C. What is the pattern of growth and the y-intercept of the graph? All right, well, we know that y equals mx plus b form. I know that the m, right, represents the growth, and the b represents the y-intercept. So my growth, when I look at where that b lines up in my rule, is negative 2. And my y-intercept, when I look at where that is, that b, where that lines up here, is 2/3. So we need to write that usually as an ordered pair. So y-intercept, remember, first the x value would be 0 because we're not moving left or right at all. And my y would be a 2/3. Just like that. All right, thanks for watching, guys. Take care.